Hello everyone, so today we are going to represent this experiment of the tennis and basketball collision.
First of all, we should know the weight of the basketball and the tennis ball. Then, we found out that the scale is irrelevant, but we know that the estimate value or the weight of the basketball is 624 grams and for the tennis ball is 58 grams. So, go back to the experiment.
Let's take our experiment in a slow motion angle. At first, we release our system that is built from a tennis ball and a basketball from a height of h in which both velocities are pointing downwards due to gravity. Let's stop here. We can see that the basketball is touching the ground first, in which it changed the velocity's direction from a downward to upward, and let's also the tennis ball jump higher at a maximum height. Let's implement the experiment into equation. So, as I explained, when we release our system, both velocities are pointing downwards due to gravity, and when the basketball touches the ground, its velocity changes from downward direction to an upward direction, in which the tennis ball jumps to a maximum height, and our study will be conducted to before and after collision. Since we have an elastic collision due to the non-deformation of our system, and we will assume from our measurement of the balls that m1 is way greater than m2, then we will have a conservation of momentum and a conservation of kinetic energy expressed in the following equations that we will try to combine them in order to find the velocities after collision. Let's take the equation of conservation of momentum. We will put the m1 factors in one side and m2 factors in the other side to make the equation A. Same for the second equation. We will simplify by 1 over 2, put m1 factors in one side and m2 factors in the other side, simplify the remarkable identity, and use the equation A so that we can get v1i plus v1f equals v2f plus v2i. Then we will replace it in the conservation of momentum equation, and after some mathematical calculations, we will get v2f in function of the initial velocities. Using the same approach, we can find the final velocity of the basketball in function of the initial velocities. Now let's solve the final velocities based on our assumption of m1 is way bigger than m2 by setting m1 to m and v1f, v2f in function of v in order to simplify the calculations. Then we choose an axis such that the upward direction is the positive and downward direction is negative. So based on our assumptions, we will find the velocity of the basketball. It's equal to its initial velocity, and the final velocity of the tennis ball will be equal to 3 times the velocity of the basketball. Moving on to the second part, let's calculate the maximum height that the tennis ball has reached. Since we have an elastic collision, it means that we have a conservation of energy. In other words, the total kinetic energy will be equal to the total potential energy. So 1 over 2 mv square will be equal to mgh, and we can deduct the height, which will be equal to v square over 2g, which is the height of the basketball. For the tennis ball final velocity, which is v2f equals to 3v, we will replace it in the height formula, and then we will get the height equals 9 times the height of the basketball, which means the height of the tennis ball will be 9 times higher than the basketball, which proves the physical phenomena.
Thank you for watching. See you next time.